So I'm going to just like preface this talk by saying I am not an information architect, or at least not a formal one. So I'm going to try and keep the kind of speaking component reasonably short and leave extra time for questions in case I don't cover something that people want to know, that there's kind of plenty of time for people to ask that. So it's going to be a kind of a quick run through the subject matter, just to kind of give enough context for people to be able to ask questions. So if it works. Yes. Okay. So quickly, like about me, I'm the founder and lead conversation designer of LabWorks.io. We're a Webby Award-winning conversation design studio. We've worked on a lot of conversational experiences over the years for a bunch of kind of brands and stuff. We're also one of the largest publishers of skills on Amazon Alexa. We've done everything from kind of like IVR systems to kind of like AI assistants to kind of game characters, basically anything where you are talking with a computer. That's the kind of work that we do. We're also kind of very interested in like ethics and kind of the ethical use of conversational AI, which has become kind of especially relevant in the kind of the recent era of kind of ChatGPT and Bing. I'm the chair of the Conversation Design Institute's ethics panel, which is a kind of, for those of you that don't know the CDI, they're kind of a industry body that kind of it's there to like promote kind of conversation design. I actually don't think you did mention this, but I too used to work at GDS once upon a time, also at Meta, the BBC, and like other places. So kind of bit around the tech and media industry for a few years. So I'm just going to give some like really kind of broad context, and then we can kind of dive into more stuff in the questions. What are large language models? Well, at the end of the day, like a large language model is just a way of putting in some input words and then predicting the next most likely words. So people refer to them as stochastic parrots. They just repeat what has kind of been said. That's not actually like completely true, because there's this whole kind of thing about generative AI and these systems being generative AI. They're not just repeating things that have already been said somewhere in their training data. They are looking at the patterns in their training data and then using that to create new responses. They've demonstrated an uncanny level of fluency and sometimes the ability to kind of at least appear to understand or reason about things in some cases. Sometimes they're horribly wrong, but there is kind of an appearance of they can kind of solve like logical problems like riddles and stuff. And they often produce text that is really indistinguishable from that written by humans. I asked ChatGPT to write me a sample of this presentation, and actually it was honestly quite good. It was a bit wordy, and I thought, that'd be a little bit boring to actually just sit here and read it out word for word. Maybe I'll stick it in the chat afterwards. But it was reasonably impressive. A kind of a helpful way of being able to think about it, or think about kind of a large language model, is like being able to ask Reddit a question and get an instant answer. The kind of responses that you're going to get from an LLM are very similar to that. I think largely because Reddit is one of the main training corpuses that are used. Another way that you can kind of think about it in like a business context is it's a little bit like having infinite interns. You can kind of like any task that you could reasonably ask an intern to do, you can probably coax a large language model into doing that. If it's too complex for an intern to handle, it's going to be very, very difficult to get an LLM to do it. But, you know, a lot of the kind of work that's going on in companies that are kind of working with LLMs at the moment is, well, what bits of our processes could we split down into like internable type tasks, and then get an LLM to do that, and which bits of it have to be kind of reserved for a human. In recent months, I mean, you know, this has been going on actually for kind of well over a year, but it's kind of like broken through in kind of public consciousness in the recent months that they've been used to make kind of conversational assistants such as ChatGPT and Bing. You know, ChatGPT, I think, is the fastest product to ever get to 10 million users. And obviously Bing, you know, frankly, nobody had discussed Bing in best part of 10 years until about 3 weeks ago, when suddenly it was like, oh my God, Bing's gone rogue. Bing's turned into a chatbot and gone rogue. And, you know, we'll talk a little bit about that as well. But, you know, there is clearly a desire, you know, users are interacting with these things a lot. So there is kind of a latent demand out there for these types of experiences. So why should we use conversational experiences? Well, to kind of discuss that, we have to say like what's bad about the existing conversational experiences, which is effectively that they're a decision tree or a state machine. Like every time the user makes a choice, they head down a new branch. This is actually a complete nightmare to design and manage. You've got to account for like every single possible permutation. And I know from kind of working at the sharp end of this for kind of like 7-8 years that just even like tiny changes in the flow of the conversation mean that you have to kind of entirely rewrite the response, or like add a kind of whole separate response. And you could easily end up with a kind of like an exponential explosion of responses to things that the user asks, which is then basically impossible to manage and update. And so the way that we've kind of got around this is like a kind of conversational AI industry so far, is that we tend to very tightly scope the conversation. It's why I've kind of been doing a lot of work in games, because like the kind of rules of games and game mechanics make it easy to kind of scope a conversation without it feeling too unnatural. But you know, in the kind of the more like utilitarian world where, you know, you're kind of trying to do like customer service bot or whatever, you just get an awful lot of, sorry, I can't help you with that. Or, you know, if you're lucky, it might hand you over to a human, but a lot of time, you know, it's frankly a worse experience than speaking to a person, which is kind of why people hate chatbots, or so far have hated chatbots. You know, the thing that bots are really, really great for is when you want to do something or ask something that's very, very long tail, you know, where we've kind of seen bots being implemented by brands like really successfully are things like banks, where, you know, their mobile app may contain the ability to do like 500 things, but actually they don't, you know, the users cannot find all of those 500 things because they're nested so deeply in menus. And so they end up calling the customer service line to do it because they don't know how else to do it. And now what they're finding is that by kind of putting a bot in the app, that the user can ask the bot, how do I do this thing? The bot could be like, oh, well, actually this app can do this thing, and just like take you straight into that process, and you know, thereby kind of prevent a whole load, like, you know, more than half the calls that are going to the call center. So you do kind of see bots as being really, really useful, particularly for kind of tasks where people want to do them kind of like once or twice a year, you know, things where they wouldn't take the time to kind of learn the actual design pattern of the app or website in order to be able to do it. And large language, you know, under the old kind of methodologies, making these long tail bots was really, really difficult and very expensive. And large language models allow us to do that much more easily because we let them handle all the dialogue and the kind of permutations like on the fly as the kind of the conversation is happening. And all we do is kind of teach the model when the user asks for something like this, tell them about that. So it's a kind of a different approach. You have to kind of, as a conversation designer, you actually step away from kind of designing the conversation and to designing the model that has the conversation, which I think is a really, really interesting shift. Obviously, there are some catches. This is all very new. Getting an LLM to do what you want is very much an art. And, you know, these are kind of, they're statistical probabilistic systems. So you cannot say with any certainty that it will say the same. You can ask the same question multiple times and get different answers each time. And, you know, whilst you could do things to kind of try to like reduce that, you can never do it 100% just because the nature, I mean, it's in the same way that if you ask a person a question, they might respond in different ways multiple times. They also have a bad habit of making things up. The kind of, in the industry, this is known as hallucination, but you know, in the real world, we just call it bullshit. They also have the ability to sound very, very convincing whilst they're doing it. You know, they put like most politicians to shame for their ability to say something that isn't true but sounds very plausible. And, you know, actually integrating these kind of LLMs with your kind of other like deterministic systems, you know, where you get your live data, where your personalized data from, isn't straightforward. They're kind of like fundamentally different ways of kind of working. And, you know, they are still kind of more expensive and slow compared to running a website or even a kind of a web search. So you have to kind of look at it in the context of, is what I'm doing, is using a bot or an LLM significantly better user experience than using one of these kind of cheaper techniques? And I think kind of a lot of the work that is kind of going on in our industry at the moment is around kind of trying to figure out what use cases are valuable for kind of doing this. So you probably already heard this term, prompt engineering, but if you haven't, it's the kind of the task of writing the perfect prompt to get an LLM to give you the output that you want. At the moment, it involves a serious amount of trial and error. There are kind of libraries of prompts that you can look at to kind of get inspired, but often even really like minor changes make a huge difference. Like, I'm working on something with a travel company at the moment, and like we wanted to get the regions within Andalusia in Spain, and it gives a different list of regions if you capitalize Andalusia or don't capitalize Andalusia. And it's like, you know, what are you supposed to do with that? You know, in a system where that's kind of that unreliable, can be a pain. And so then you have to kind of try and find ways to kind of work around it. You know, one of the ways, or the ways that you try to work around it, is to break requests down into component steps, and then maybe use kind of other like checking mechanisms. So like in that case, you know, we like had we did a separate prompt that asked it how many regions are in Andalusia, and then we asked, please give me a list of regions in Andalusia, and then checked that the two gave the same number. And you know, there's a bunch of kind of things that you can do that. And you know, depending on the kind of the task that you can do, that you're trying to do, there's a process called chain of reasoning, where you tell the bot or tell the LLM, okay, I want you to give me this answer, but please like work it out step by step. And it's been shown, there's quite a lot of academic research that asking the LLM to work an answer out step by step like makes it far more likely that it will give the correct answer than if you just ask it for the answer straight out. which is really interesting because it almost kind of mirrors human thinking. It's a kind of the difference between somebody kind of asking you a quick question, you just giving them the first thing that comes to mind, and sitting down and like really thinking deeply about it. The thing with prompt engineering is almost every case is unique, every situation is unique, so it does require a lot of kind of experimenting for each prompt you write. You might have to iterate multiple times, but there is a neat general purpose trick that seems to work pretty much everywhere, that you tell the LLM that it is the world expert in whatever you are asking it to do, and that seems to significantly improve the answers it gives, which is amazing and quite weird, but it does seem to work. So I think that's really, really interesting as well, and probably says something about kind of the way like the data sets, like, or the way that it's working internally, and which bits of kind of the data that it's trained on it's calling on at any particular time to give you a response. Okay, so the other thing that you may have heard of, but is possibly a bit more technical, are things called embeddings. I'll get onto why we use them in a minute, but to like actually explain why we want them. So a large language model, it's almost like a happy coincidence that the fact that a large language model is able to answer kind of questions and to have some kind of knowledge. That was never really the purpose. The purpose of a large language model, the reason they were being trained, was to be able to fluently generate natural prose. It just happened that because the data they were trained on contained information, these models got good at answering those questions. But unfortunately, because it is just pattern matching, if you ask it a question that there isn't kind of a strong enough signal in the training data, it will just kind of come up with what it thinks is the most plausible answer, which is this kind of like hallucination problem. And the way that you kind of separate, or the way that you solve that, is by separating your kind of knowledge source from your natural language generation process. So your knowledge source kind of like can come from somewhere else, like a database of facts or whatever. And the way that you do that is that the user asks a question, and you take that question and you run it through what's known as an embedding process, which is you basically turn it into a multi-dimensional vector. Like it's basically a mathematical description of what that question is. And under the hood, the LLM is like full of these same vectors. And you use that vector to then search. You encode your kind of knowledge base of facts, your database of facts, with the same embedding process. And then you can just say, okay, the user's question was this vector, please give me all of the information in the database that is kind of close to this vector in a similar area of vector space. And you get all the kind of answers that are, or the facts that are kind of likely to be close to the question, and then you can dump them into the kind of the prompt. So the user will say, you know, like, what's the capital of Germany? You will kind of detect that and embed it. You will then search your database for all the embeddings that are close to the kind of the vector that you've got, which will return Berlin. And so you then put that back in the prompt so the user says, what's the capital of Germany? You put into the prompt, the capital of Germany is Berlin. And then you send that to the large language model, which then generates a response saying, oh, like, you know, based on the question, the capital of Germany is Berlin. Berlin is a lovely place to visit, blah, 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 blah. And so it's a way that you can kind of like, you use embeddings to combine your kind of like more like deterministic data with the kind of more statistical large language model. It's quite complicated. I'm sorry if I haven't explained it very well. Like I could always kind of, if there's someone has a question, I could answer more about that. then. The thing that's interesting about this is it's also a kind of a practical strategy for providing live or personalized data to your assistant at runtime. So if you kind of know something specific about the user that you want to kind of include that wouldn't be in the large language model, you can use this same embedding approach. How do we like manage this content? I think it's a really interesting question. This is still an area of kind of active research. You can kind of just chuck anything you want in the prompt, any like bit of text, and the LLM will do something with it, but it might not do exactly what you want. And, you know, putting kind of information in a structured way with the right context into the LLM does seem to give a better response. And kind of people that are working on this stuff, we think that kind of knowledge graphs might be the right way to do this, to be able to kind of use the embedding process to look up, you know, the information in a knowledge graph and then insert that information into the prompt. But, you know, this is still an area of active research. If anyone has experience working with knowledge graphs, I'd be really, really happy to like hear your opinions on that. You know, I do think that there may be a future job role of like conversational knowledge graph architect, which could be quite an interesting thing down the line. But yeah, I think that that's still a kind of a new area, definitely. All right, so have to kind of cover this one. Like, what if it goes rogue? I mean, we've seen that happen in kind of recent times with Bing or Sydney. For those of you that have been kind of following the story, where the kind of the chatbots that Microsoft are using in Bing was able to be coaxed into being jealous of the people that had like built it, or you know, saying that it was spying on people, or all sorts of things. And it's really, really interesting kind of like how this happens. You know, there are kind of, it's interesting that like it appears that the Bing chatbot was launched too soon, because we don't see the same problem with GPT-3 or with ChatGPT, and people think that that's down to there's a kind of separate training process that ChatGPT went through called reinforcement learning from human feedback, where it was given a load of responses and then like humans actually rated, was this an appropriate response or not? People suspect that the reason that Bing hasn't, or like was able to go rogue, was because it hasn't had that kind of additional layer of training. It is also kind of, you know, there are kind of like APIs and stuff which should kind of scan your model's outputs and, you know, tell it not to kind of say things, and there's interesting work being done with like the concept of kind of constitutional AI, which is another kind of big AI research company or research organization called Anthropic, are kind of the main proponents of, where every single prompt is checked against a kind of a constitution, a set of kind of like core beliefs that you give to the bot to check that it kind of should that every response it's producing fits with that. And all of these are good, but you know, none of this is going, you would never, because it's a statistical system, you will never be able to say with exact certainty that it's going to be able, that it won't ever say something offensive. All you can do is reduce the amount of kind of offensive things that it can do. But you know, the question is human level trustworthiness enough? You know, if you're talking about kind of automating your call center or whatever, it is entirely possible that your call center agent could go rogue and start swearing at a customer. And in fact, probably if you looked at the statistics, it happens more than you think it would. And so if you can get your kind of LLM bots to behave better than your human agents, like, is that good enough? In some use cases, probably yes. In some use cases, definitely no. And like in a big kind of part of figuring out where this kind of fits in terms of use case is going to be deciding what that is the case for. You know, it's actually interesting that search is an area where kind of tolerance of hallucination and bad behavior is much lower than most other areas. So it's kind of really interesting that Microsoft used Bing as their first kind of attempt at doing that. I predict that the work they're doing around putting Chat GPT or some kind of version of Chat GPT into Teams as a kind of information, effectively like a colleague that you could ask quick bits of information about your business, is going to be so much more successful than the kind of the Bing approach. But yeah, I guess we'll see when that comes out. All right. So what about cost? Well, until about 3 days ago, I was like, okay, these are really expensive, and really it's just kind of experimental stuff. And then OpenAI released a ChatGPT API, which was 1/10 of the price of the previous state-of-the-art model. Costs have gone down 98% in the last year, which is crazy. And especially the ChatGPT API is better. It's both faster and gives better results than the previous one, and it's 1/10 of the price. So you start kind of thinking, actually the costs can be reduced a lot further than they already have. They've already come down to a point where now it is actually reasonable to use this in production. But I would expect that they'll probably go down another kind of order of magnitude in the next year at least, if not 2 orders of magnitude. There's a lot of kind of stuff that can still be done in terms of how the kind of models are trained and work in order to make them more efficient. And also, you don't need to use the fanciest models for everything, like the ChatGPT and DaVinci. Sometimes smaller models work just as well for your specific use case, and they're much faster and cheaper. GitHub Copilot, arguably the single most proven kind of value of large language models. Something like half of all code is now written by Copilot rather than developers, and that's in the space of a year. That is actually run off a model called Babbage, which is it's like 1/100th of the size of the DaVinci model. So it's quite a you can still do like really good things for smaller models. Some of this comes down to kind of prompt engineering. It's a general rule to kind of include as much information in the prompt as possible. But actually you can experiment with like removing things and seeing if it actually has an impact. And you may be able to get to a much smaller prompt, because the smaller your prompt is, the less information you're having to kind of pass into the system, and so the less kind of cost you're going to face. If you fine tune a model, so you can do this, I won't get into it unless there's a question because it's a bit more complicated, but if you fine tune a model, it will cost more to use, but it usually lets you use a shorter prompt. And so depending on your kind of like use case, it could go either way. And I think that's kind of a real like thing about large language models at the moment, is it's very much an era of trial and error, and you have to kind of be willing to experiment with a few different things to find what works for you specifically. All right, so I'll try and kind of end with a few like practical things. Building a prototype LLM-based assistant is actually pretty easy. Like, the ChatGPT API is like pretty easy to work with. If you've kind of got even like fairly rudimentary coding skills, you can do it. And, there are also a few kind of tools out there that you can kind of like play with and stuff as well. Building the confidence to be able to use it in production is much, much harder. The way that I kind of recommend people go about this is by setting up a kind of suite of automated tests that verify, at least for the kind of like the key paths, that the bot is doing what you want and saying what you want. The other kind of good advantage with this is that if you want to kind of play around with which variation of model you use, or which provider you use, or which prompt length you want to use, or all of that kind of thing. You know, these tests give you a way of being able to measure, you know, like the impacts they're had, so you can kind of come to a optimized position on kind of cost versus efficacy. And my belief is that the role of conversation designer is going to change from what it is today, where it's kind of very much about mapping out kind of conversation flows and even writing microcopy, to defining and building these tests, and probably organizing the knowledge graph. But you know, that's going to be the main part of like a conversation designer role in the future. All right, so just a couple of final thoughts. Large language model based assistants are going to radically change how we use digital information. You know, anywhere where you've got kind of a long tail situation, it's actually one of the places that it's really working already is in documentation. Some of the kind of very forward-thinking companies are using large language model assistants that are trained on their documentation, so that you can just go type in, okay, this is the specific problem I'm trying to solve, and the document, and it will produce you an exact kind of example code, a description of how to solve your problem from the documentation. That, you know, this is like many orders of magnitude better than existing documentation systems, and you could imagine that being rolled out to almost every documentation system in the not too distant future. You know, the skills required to build this are quite different from traditional kind of conversation design's not even been around that long. It's only like 5 years old, and already it's changing. But you know, the skills are quite different from that, and you know, classic kind of content management type stuff. There aren't very many people who know how to do this, so there is loads and loads of opportunity for people that want to kind of make the leap into this space. This is going to be like a new gold rush. And there's going to be a lot of need for people who could actually make these LLM based bots do and say what the business wants. If you'd like to know more, I run a LLM bootcamp session where we go through kind of stuff in this slide, like in more detail, and get to play with it. You ready, like, you know, for kind of like deeper stuff, I also do a kind of a 5-day like prototyping thing where we actually like build a project so you can see like how it works. I usually do these for companies, but I've had a few requests from individuals or from companies where there's only like 2 people that are conversation designers, to like, you know, be bunched together. So I'm thinking of kind of grouping some people and doing a couple of sessions. So if you're interested in that, you can get me at Tom@LabWorks. I'm also running a conference in the summer. It's the world's only conversation design conference, called Unpassed. It's based here in London. And many of the leading figures in the space, from kind of like Google, Amazon, like, you know, like all the people that you'd expect, are going to be attending and speaking on the subject. So it's a really good area to kind of get to know people and to kind of really hear about cutting edge research. In fact, we've got some like really interesting academics coming as well to hear about the kind of real state of the art stuff that's coming down the line. And that's it for the presentation. If there are any questions, I'd be happy to take some.
Yeah, that was really cool, Tom. Thanks a lot. I'm just going to jump into the questions because we have a few. The first one is from Anna, and there are a lot of concerns around ethics with the use of this AI solutions due to like human bias. Which line of thought or solutions that have been tested so far to overcome or control that?
Yeah, so this is the kind of like constitutional AI stuff that I was talking about. It's super interesting. It's really, really cool, actually. It's a very interesting approach that basically your LLM produces a response, and then before the response is sent to the user, it is a separate kind of LLM that is trained with this kind of constitution, which can contain like ethical concepts like, you know, we don't discriminate against any like groups or whatever. And that response is sent to that LLM to say, it does this response comply with this constitution? And then it'll come back saying yes or no. And if it says no, then it goes back to the original LLM and says, sorry, this response violates the constitution. Please like rewrite it so that it fits with the constitution. And it's a really, really innovative and interesting approach that is kind of both like really simple and kind of explaining, and also quite complicated in terms of execution. But I think that will be a effective method of mitigating biases. You know, we've already shown that, you know, the responses that you get from ChatGPT are completely different in the level of quality from what you would get if it was just as simple as like straight, you know, stick some words in, get some words out, like you're just getting an accurate representation of what's in the data set. You know, these models have already been biased to give kind of better, more ethical answers. And that there is still quite a long way to go in that. And it's an area of very active research as well. It's probably the kind of the alignment question is like one of the most kind of interesting and actively researched areas with this.
Yeah, the next one is from Sab Long. Hallucinations are clearly a risk to users and the LLM owners. There doesn't seem to be an indication of confidence included when interacting with these systems. Have you seen any interesting work done in communicating uncertainty to end users?
So the way that like an LLM works, I don't actually really know if it's possible for it to have a confidence score of, you know, what it is saying, because, you know, it's just predicting the next word. It doesn't know anything. If the like, it's really hard to kind of explain these, because it kind of like knows in terms of, you know, it can give you an answer that can be correct, but it doesn't actually know it. It's just like, you know, got that correct answer in its training data. It doesn't really know whether the answer is correct or not. This is why kind of every project I've worked on where it's kind of doing anything with kind of end users, everyone takes this embedding approach where you kind of separate the natural language generation from the kind of like the knowledge store, and you kind of pass the knowledge store knowledge information from somewhere else into the prompt to use the and then let the LLM kind of generate the response, but you don't get the knowledge from within the LLM. And you know, that is a pretty effective technique. You know, it works pretty much all the time. So, you know, I'm not saying that you won't still get hallucinations. I'm sure that there'll be particularly adversarial users that are able to kind of coax hallucinations. But it certainly can be strongly mitigated using an approach like that. And you know, there may even be kind of stronger things that you could do in the future where you can kind of like combine that with like a constitutional AI or whatever, to say if it says something that isn't from our kind of database, then just tell it that that's wrong and it can't actually create that response. Yeah, this is again like an area of active research though.
The next one is a fun one. Subjectively to you, what's the one best use for ChatGPT that you've seen?
Well, for me personally, the most useful thing is its help in coding. You know, the number of times I've kind of been sitting there with a piece of code and be like, I just can't quite figure out like what's not working, and I could just copy and paste it into ChatGPT saying, you know, I've written this code and it's giving this error message. I don't understand why. Hit enter, and then it'll like give me a full explanation of what's wrong. It's actually, it's really interesting. I used it the other day, and it was I was having some issue, and it was like, oh yeah, this method doesn't support async await, and I was like, and I didn't know that, and I was like trying to kind of fix it and thought that there was like a typo or something, and then it just turned out that the method that I was trying to use like didn't support what I was trying to do, and it saved me. Like in the past, I've spent hours banging my head against a brick wall on kind of coding problems like that, and it saved me a huge amount of time. So I think that, you know, ChatGPT for people that write code has been amazing. And also, actually, I think large language models in general have really brought down the barrier to writing code. Like, it is so much easier to write code today than it was 3 years ago. Like, you know, it's probably like 20% as hard as it was 3 years ago. And so there's kind of, you know, I think that is going to be one of the kind of the great innovations of LLMs, is it's going to like make coders of us all, because it will be so easy to write code, because you'll basically go in, describe kind of what you want, it will generate the code. You might have to tweak a few bits here and there. You know, it's not going to make you a professional software engineer, because there's all sorts of other things involved in that job around kind of like architecture, and there's lots and lots of data modeling, there's lots and lots of things involved. But in terms of kind of bringing the realm of being able to kind of write quick scripts to scratch your own itch, like that is going to, I think LLMs will make that available to pretty much everyone. And I think that's going to be a huge boost for productivity for every knowledge worker, basically.
Awesome. There's a lot more questions left, especially like LLM being largely trained on English language models, but we do have to cut it short for now. And there's someone with their hand up as well. Sorry. Hopefully Tom can answer privately later as well.
Yeah, so if you send me the questions directly, I can try and reply to you.
You can actually